Hello, it's Science Mr. Robertson here for some more science videos. It's time for more about the body, and it's the skeleton, and it's about muscles. And we're going to look at those today. Firstly, we're going to focus on our skeleton and why we bother having a skeleton, because not all animals do. But we have lots of bones in our body, and they do many different jobs. One of those jobs is for protection. So they help to protect different parts of our body. A great example of this would be, for example, the skull, keeping my brain safe. It could be the ribs, which of course protect my heart and my lungs in here. It could also be my backbone. All of the little bones up here that protect my nerves in the spinal cord. Very important. However, it's not just protection. It's also support. To keep me standing up straight. If there was no bones here, no amount of muscles would keep me upright. I wouldn't be strong enough. So I also have support to keep my body in shape. I also have the idea here of movement. My bones help me to move. My muscles attach to the bones. So the muscles move the bones so my body can move. Really good. In fact, the ribs are actually really important for that. So the ribs are the bones we have, of course, protecting the heart, protecting the lung. A little bit like this. It's not great. It will do. But that's really good. If it was like this instead, it would do better protecting. Like all of this here, one big piece of bone. Really good protection. But really, really hard to move it. These little bones here, really easy to move so you can still breathe really good. And breathing, protection, they're both important. There's a balance in between. The final thing that the skeleton does is actually where we make blood. Red blood cells, white blood cells are made inside of our bones. So that's a very, very important thing there about the skeleton, the ability for us to make new blood. And they've gone through some different types there. But the skeleton has to work together with, of course, the muscles. And the classic thing to talk about when we talk about the skeleton and the muscles working together is the arm. So I can have my hand here, a Simpson's hand, only 4 fingers. And I'm going to give it a really, really big elbow here. Not my worst. Not my worst. And of course, as we know, we can move our hand, can go up, and it can go down. I can move it up, and I can move it down. Up, down. Really easy. And the muscles are attached to the bones. It's this muscle and this muscle that are doing the movement. Not any here. Those muscles stay still. It's these muscles here which are moving. They are, you might know these words, they are called the bicep at the top and the tricep underneath. So they have 2 muscles like so. If I am doing moving up. So the hand is moving upwards towards the body here. Then this here has to pull to move it up. This muscle here has to come closer together to get everything to go in. So here I say the bicep. The word I use for that is that it contracts. Contract, inte som att skriva en kontrakt för ett jobb. Contract as in get smaller. What actually happens in the muscle fibers is that the muscles like this, and you give it energy, it can move up and down. So when you contract the muscle, it goes in like so. The opposite of contract is when it stretches and it relaxes. We would say here the bicep contracts, but we would say the tricep relaxes. And that would mean this one here was shorter, this one here was longer. The result of that would be a hand much higher up. And the opposite, if I stretch it this way, the bicep now relaxes and the tricep underneath is tight. They're a great team. They work together, and most of the muscles in our bodies, they do work together. But oh my goodness, muscles sometimes they get tired and they stop working. That happens because, hey, muscles need oxygen. They need energy to move. They need oxygen. So when you exercise, hey, you need more oxygen. So you start breathing faster to give more oxygen to your body. More oxygen, great. But the oxygen doesn't go from here into your muscles, into your lungs, and then the heart gets it, and the heart pumps the blood around. So you're breathing faster, and your heart is beating faster, trying to get that blood as round your body as fast as it can. But it can't do it so fast that you can always keep running forever and ever. There's a limit for every person on the planet. There's a limit. When there's a limit, if there's not enough oxygen, then the actual problem is you actually make something else. You don't make carbon dioxide because your brain's like, make energy, and it will do anything it can to make energy. These muscles will do everything possible. They will push you to the limit. But that limit is actually, they don't make carbon dioxide. They don't have enough oxygen to make carbon dioxide. They actually start making, in their muscles, lactic acid, which for svenska you might know as mjölksyra. That is an acid. The acid, what it does, it basically stops this. It gets harder and it stops. The muscle stops working. That can happen, for example, if somebody has a cramp. Usually there's too much acid built up, the muscle stops working. You need to wait, get more oxygen there. More oxygen, the muscle will go back to normal, all is good. But of course, if you train, make that muscle bigger and stronger, you can work harder. Work harder. Thank you.